Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera saya ucapkan kepada pelajar-pelajar yang dikasihi sekalian. Okey, saya harap semua pelajar berada dalam keadaan yang sihat walafiat dan sentiasa menjaga SOP walau di mana sahaja anda berada. Okey, ingat, kita jaga kita. Alhamdulillah, kita bertemu lagi pada hari ini dalam program Leptons dan Meka, anjuran unit Fizik Kolej Matrikulasi Melaka. Hari ini merupakan siri kelima kita menjayakan program ini bagi semester 1 sesi 2020-2021. Alright, hari ini para pelajar akan dibimbing oleh dua pensyarah fizik yang tidak asing lagi di kalangan pelajar-pelajar SDS. Okay, iaitu pensyarah yang pertama, Sir Muhammad Faizal bin Abdul Jalal atau lebih dikenali sebagai Sir Jejai. Okay, beliau memang glamour di KMM ini. Dan pensyarah yang kedua adalah Madam Siti Nurul Akmal binti Cik Abu Bakar. Okay, beliau berdua akan membincangkan chapter 6 iaitu circular motion. Okay, jadi saya mohon pelajar-pelajar dapat bersedia dengan kertas, buku, alat tulis dan kalkulator, okay, atau apa-apa saja yang bersesuaian bagi memudahkan para pelajar menimba ilmu dari mereka berdua ini. Okey, dengan itu saya mempersilakan Madam Siti Nurul Akmal untuk meneruskan perbincangan. Dipersilakan.
Okay, thank you to Miss Hanisa as the moderator for this week. Okay, so I'll briefing a little bit about the content for chapter 6, circular motion. So, what are contained in this chapter? Okay, the first thing that you must know is about the uniform circular motion. So, what is meant by uniform circular motion? Okay, so uniform circular motion is the motion of an object in a circle, okay, when the object move in a circle with constant speed, okay, with a constant or uniform speed. So when the object move in circular motion with a constant speed, so we call it as uniform circular motion. Okay, so other than that, okay, when an object moving in circular motion, so it will experience a centripetal acceleration. Okay, so what is centripetal acceleration? Okay, so centripetal acceleration is defined as acceleration of an object that moving in circular path and it is directed towards the center of the circle. Okay, so centripetal acceleration is denoted by AC. Okay, AC, the equation for AC is equal to V squared over R. Okay, that is the equation for centripetal acceleration. Okay, next is centripetal force. Okay, centripetal force is FC. So, FC is defined as the net force required to keep an object of mass moving at a speed v on a circular path of radius r. Okay, so centripetal force is the net force required by an object to moving in circular motion, and direction of centripetal force also same as the centripetal acceleration, which is directed towards the center of circular path. Okay, and the symbol for centripetal force is Fc. Alright, so we continue with the formula that will be given in PSPM. Okay, selected formula in PSPM for this chapter is only Fc is equal to mv squared over r equal to mv omega and also equal to mr omega squared, which is m is the mass, v is the speed, omega is the angular velocity, and r is the radius of circular motion. Okay, so that's all for the content for this chapter. So we'll continue with a discussion of question after this. Okay. Okay, we will start our discussion with PSPM 2010-2011 question. Okay, I will discuss a few questions that are related with horizontal circular motion case. Okay, and then it will be continued by Sir Faizal with vertical circular motion case. Okay, so let's have a look to this question. Okay, it is a 0.2 kilogram ball attached to the end of the string is rotated in horizontal circle of radius 1.5 meters on a frictionless stable surface. Okay, the string will snap when the tension exceeds 50 newtons. Okay, so let we analyze the information that are given. So firstly, we have 0.2 kilogram ball, so means this is the mass of the ball attached to the end of the string rotated in horizontal circle. Okay, so it is a horizontal circular motion case with radius 1.5 meters. So this is r radius on a frictionless stable surface. So we will ignore the friction. Okay, the string will snap when the tension exceeds 50 newtons. Okay, so this is 50 newton is the maximum tension in the string. So if the tension is exceed 50 newton, the string will snap or break. Okay, the first question, what is the maximum speed of the ball? Okay, maximum speed of the ball, we are going to find V, right? So, how to find V, speed? Okay, so from the equation of centripetal force, okay, Fc is equal to mv squared over r. Okay, Fc, what is Fc? Fc is centripetal force, as the meaning of the centripetal force is the net force required by an object to move in circular motion. Okay, net force. So now we are going to find what is the force that is contribute to centripetal force that can make the ball rotate in circular motion. So we have to draw the diagram. Okay, let's figure out the diagram to make it clear and easier for us. Okay, so we have the ball attached to a string will in a circular motion with radius. Okay, now we know that the radius is equal to 1.5 meters. Okay, so let's identify the forces that are acting on the ball. Okay, the string, so there will be a tension in the string, and then of course it will has the weight acting downward. Alright, so now identify the direction of centripetal force. Centripetal force is directed towards the center of circle, right? So since the center of circle is at the right side, so Fc will be directed to the right. So force that in the same direction as the centripetal force, now we have only tension. Okay, so it means that our centripetal force is equal to tension. Okay, tension will be the centripetal force. Okay, so here we will substitute our Fc is equal to tension. So tension is equal to mv squared over r. Okay, so now we will substitute all values. tension is equal to 50. Okay, mass is equal to 0.2 kilogram. Okay, V squared, the quantity that we are going to find, and our radius is 1.5 meters. Okay, so by calculating, the value of V will get 19.4 meter per second. Okay, so we got the correct value. Okay, B. Question B, if there were friction on the table, what will happen to the maximum speed of the ball? Explain your answer. Okay, just now, in previous question, we ignore the frictional force. But now we have to consider the friction on the table. What will happen to the maximum speed of the ball? Okay, so what will happen to the maximum speed of the ball? Okay, second question, B. Okay, if we now consider the friction, so what will be the direction of friction on the ball? Okay, so this is, I draw again. This one is tension right now. And this is the weight. Okay, what is the direction of friction? Friction will be directed to the left side. Okay, why? Why direction of friction to the left? Okay, without friction, there is a tension, right, acting on the ball. So because of tension, the ball will tend to move to the right, isn't it? If there is no friction, the ball will tend to move to the right. Okay, then when the friction exists, as we know that friction will act in the direction of opposite with the direction of motion. Okay, so that's why friction will acting to the left untuk prevent, untuk halang bola tu daripada masuk ke dalam. So friction will acting to the left side. Okay, so now when friction acting to the left, it will affect our centripetal force. Now our centripetal force Fc is equal to mv squared over r. So now our centripetal force is equal to tension minus friction, right? Equal to mv squared over r. Okay, so just now tension value is 50 newtons. But now if we minus with a certain value of frictional force, of course our net force will be less than 50 newton now, isn't it? So our centripetal force now is less than 50 newtons. And since mass and radius are constant, okay, so our Fc is directly proportional with speed squared. And now Fc, our Fc is decreasing. So what will happen to the speed? Okay, our speed will be also decrease. Okay, so speed, maximum speed will decrease, decreasing. Okay, because speed and Fc is directly proportional. Okay, so we continue with PSPM 2013-2014 question. So the question is, a 60 centimeters conical pendulum bob revolves freely. The pendulum string makes an angle of 37 degrees with the vertical. So here we are given a 60 centimeter conical pendulum, so mean it is the length of the string. Okay, makes an angle of 37 degrees with the vertical. So let we figure out the question first. So we have a pendulum bob, okay, makes an angle of 37 degrees with the vertical. So it's revolve in a circular motion. So the angle will be here. Okay, 37 degrees. Okay, so first question is sketch and label a free body diagram of the pendulum bob. So in order to sketch a free body diagram, so we have to identify all forces that is acting on the pendulum bob. Okay, so since there is a string of the pendulum, so there will be a tension along the string, right? And there will be weight. Okay, so let's draw the free body diagram. Okay, sketch the axis first. Denote a dot as our object. So there is a tension will be directed here. Okay, tension here, and the angle will be attached to y-axis, 37 degrees. Okay, so we have to label the angle in our free body diagram. Okay, and then we also have weight acting downward. Okay, settle for our free body diagram. Okay, second question, calculate the speed of pendulum bob. Speed of pendulum bob, so means we are going to find V. Okay, V. Alright. So to find V, we have to use equation of centripetal force, right? Fc is equal to mv squared over r. Okay, but now we have to find what is our Fc. Okay, so in order to determine Fc, we can determine Fc from free body diagram. As we know that Fc is the net force required by the pendulum to make it move in circular motion. So from the free body diagram, the direction of Fc will be directed towards the center of circular motion, will be directed to the right. Okay, so the force that is directed to the right will be Tx, isn't it? Okay, so our Tx will be T sine 37 degrees is equal to mv squared over r. Okay, so we have to find a few quantities here to substitute into this equation. We have to find T, okay, mass, and also r. Okay, so this will be our first equation. Okay, equation first, number 1. Alright, so to find tension, okay, tension can be found from the summation of Fy from our free body diagram. So summation of Fy is equal to 0. So Fy will be equal to Ty minus weight equal to 0. So Ty is equal to T cos 37 degrees, okay, equal to mg. So tension will be equal to mg divided by cos 37 degrees. Okay. And then next, mass. Mass is not given, so it's okay. So we have to find R. R can be found from the triangle here. Okay, triangle of this one is represent the length, okay, which is equal to 0.6 meter. 0.6 meter, and here is our R, and this is equal to 37 degrees. So from sine, right? Sine 37 degrees will be equal to R over 0.6. So R will be equal to, okay, by substituting, multiply 0.6 with sine 37, we'll get R is equal to 0.36 meters. Okay, so we substitute value of tension and also the radius into equation 1. Okay, by substituting, tension is equal to mg, kg is 9.81, sine 37 degrees, okay, tension just now over by cos 37 degrees, okay, equal to m v squared over r. R is 0.36 meter. Okay, so by simplify this equation, m can be cancelled out. Okay, by calculating this value, we will get the value of v is equal to 1.63 meter per second. Okay, will same as the suggested answer. Okay, next question. We proceed with calculate the angular velocity of the pendulum bob. Angular velocity, so we have to find omega, right? Omega. So how to find omega? Okay, third question. We want to find the omega. Okay, omega equal to what? So omega can be relate with v, right? Linear speed. V equal to r omega. So omega will be equal to v over radius. So since our speed is 1.63 divided by radius is 0.36. So the omega will be equal to 4.53 radian per second. Okay, so that is the answer for angular velocity of the pendulum bob. Okay, so it's a little bit different with the answer given, but it's okay. Okay, kalau ada beza 0.001 something. Okay, so we proceed with the last question. If the angle remain unchanged, but a longer string is used, will the angular velocity decrease, same or increase? Justify your answer. So now angle is constant but longer string is used, L is increasing. What will happen to the angular velocity? Okay, so look at to what will affect it if the string used is longer. Okay, the fourth question. Okay, so if we use the longer string, what will affect? Radius, right? Here, radius will affect if the longer string is used. So from we can relate with this sine 37, okay, because the angle is constant. Sine 37 degrees is equal to r over 0. Let's say the length is increasing 0 to 0.8. Okay, so we will get the longer r, isn't it? The r will be greater. Okay, so from equation of angular velocity, okay, v omega is equal to v over r. Okay, so since now our radius is increasing, what will happen to our angular velocity? Angular velocity will decrease, isn't it? Because omega and radius are inversely proportional. Okay, omega will be decreased, angular velocity will be decreased because omega is inversely proportional with R. Okay, so that is our answer. Alright, continue with PSPM 2017-2018. Okay, so the first question is define centripetal acceleration. So centripetal acceleration can be defined as an acceleration of an object that is moving in circular motion. Okay, and the direction of centripetal acceleration is directed towards the center of circular motion or circular path. Okay, so that's it for question A. Question B. Okay, figure 6 shows a 4 kg object is attached to a vertical rod by 2 strings. Okay, so we have the upper and lower strings. The object rotates in a horizontal circle of radius 1.3 meters at a constant speed of 6 meters per second. Okay, so we have radius of circular motion and the speed v of circular motion. Okay, calculate the tension TA in the upper string and TB in the lower string. So here, okay, it denotes as TA for the upper string and TB for the lower string. So firstly, we have to sketch a free body diagram. Okay, sketch a free body diagram to help us deduce the equation. So we have here is TB. Okay, angle is 50 degrees with respect to x axis, and for the upper string we have TA with the same angle, also 50 degrees. Okay, and one more force acting on the object, it is weight. Okay, so we have weight acting downward. Okay, so now in order to find the tension, okay, we have to relate with centripetal force. Okay, because the object is moving in circular motion, so there is a centripetal force experienced by the object. So from the equation of centripetal force, Fc is equal to mv squared over r. Okay, so what is our Fc? The forces that are contribute to centripetal force for the object to moving in circular motion now is along x component, right? So force that are in x component, we have TA, okay, TA cos 50 degrees, okay, plus dB cos 50 degrees is equal to mv squared over r. Okay, so substitute the value that we have mass, speed and radius. So TA cos 50 we will get 0.643, right? Make sure your calculator is mode degree. So TA plus 0.643 TB, okay, equal to mass is equal to 4, V is 6 squared, divided by radius is 1.3. Okay, so we'll have the first equation here, 0.643 TA plus 0.643 TB equal to 110.77, isn't it? Okay, so this will be our first equation. Okay, we cannot solve this problem yet because we have two unknowns. Okay, here we have TA and TB, so we have to find what is TA and TB first. So we have another question. we have to find another question from summation of Fy. So summation of Fy is equal to 0. So Fy is equal to, okay, so for Fy we have TA sine 50 degrees, okay, minus TB sine 50 degrees minus wake equal to 0. Okay, why it is minus here? Because the direction of TBY and wake is downward, right? Okay, so let substitute the value. So sine 50 is equal to 0.766, okay, TA minus 0.766 TB, okay, equal to mg. Wake is equal to mg, or mass is equal to 4 and g is 9.81. So we will have 0.766 TA minus 0.766 TB equal to 39.24. So this is our second equation. Okay, by solving equation 1 and equation 2 simultaneously, okay, we will find, okay, you may use your calculator, okay, mode solve the simultaneous equation from your calculator mode. Okay, you will find TA will be equal to 111.78 Newton. Okay, Newton. So it will answer our first question. Okay, second question, we want to find T2, right? T2, sorry. So T2 can be TB. What is TB? So since we already have the value of TA, so we may substitute value of TA in either equation 1 or equation 2. It's up to you. So let's say we substitute using first equation. Okay, we use 0.643 TA. So TA just now we get 111.78, okay, plus 0.643 TB, okay, equal to 110.77. Okay, then we will have our TB, okay, tension along the lower string, okay, we will get 60.55 Newton. Okay. Last question for horizontal circular motion from PSPM 2018-2019. Okay, figure 7 shows the top view of a U-turn at a road divider. The radius of the circular curve, okay, is 5.3 meters. A 950 kilogram car maintains a speed of 15.3 meter per second along point A to C. Okay, so the car is moving from A to C. Okay, so the radius is equal to 5.3 meters. So this one is R. Okay, radius of the U-turn path. Okay, the speed of the car is 15.3 meter per second. First question, copy the path and indicate the directions of velocity and acceleration of the car at point B. So point B is here. Okay, so we have to copy the path first. Okay, so from A to C. Okay, so let we denote the point. Okay, this one is point A, this is point B, and this is point C. So we have to indicate the direction of velocity and acceleration at point B. At point B is here. So direction of velocity at point B, the car is having a circular path, semicircle, right? So the direction of velocity at the circular path, it will be tangent to the curve, right? So that's why V will be directed straightly downwards. Okay, how about acceleration? Acceleration of the car at point B is centripetal acceleration. So centripetal acceleration, direction of centripetal acceleration will always directed towards the center. So center of U-turn is here. Okay, so AC will be directed towards the center. So direction of AC will be directed to the right. Okay, that is A. For question B, calculate the centripetal acceleration. Okay, centripetal acceleration of the car at point B. Centripetal acceleration of the car at point B. Okay, this one is question A just now. So now it's B. Centripetal acceleration is AC. What is the equation for AC? AC is equal to V squared over R. Okay, so V is the speed. Speed of the car is 15.3 squared. Okay, divide by the radius is 5.3. So the value of AC will be equal to, okay, calculate, and we will get 44.17 meter per second squared. Right? That is the centripetal acceleration of the car at point B. Okay, for question C, calculate the centripetal force. Okay, centripetal force on the car at point B. Okay, so centripetal force is FC, isn't it? So FC, the equation of FC equal to MAC, isn't it? Or mv squared over R. So since we already have AC, so we'll use FC equal to MAC. So M is the mass. Mass is equal to 950, okay, times with AC. AC is 44.17. Okay, so the force, centripetal force, will be equal to 4.20 times 10 power of 4 newtons. Okay, unit for centripetal force is Newton. Okay, next, the last question. Determine the magnitude and direction of frictional force on the car at point B. Okay, mana pula datangnya frictional force ni? Okay, so if you cannot find F, let's we figure out. Okay, figure out the forces that are acting on the car at point B. Okay, so this one is question D. Okay, at point B, at point B, here car, so we have the normal force, right, upward. Okay, and then we will have, okay, normal is upward, we have weight downward, Okay, and one more force is this frictional force. Okay, this force, actually the frictional force is the force that is contribute to Fc. Okay, so here the frictional force is equal to Fc, centripetal force. We already calculate the value of Fc, right? So the frictional force is equal to, same the value as the centripetal force lah, is equal to 4.20 times 10 power of 4 newtons. Okay, and the direction of frictional force, it is directed. Okay, the direction is directed towards the center of U-turn path. Okay, so towards the center of U-turn path, because F frictional force is the centripetal force, and centripetal force will always directed towards the center of circular path. Okay, so that's all for horizontal circular motion. Okay, so then next we will continue with vertical circular motion by Faizal. Okay, thank you.
Assalamualaikum and salam sejahtera. Okay, let's continue our lesson by the next subtopic. So let's discuss about a circular motion in vertical plane. Okay, as we know, there are so many different cases for circular motion which is in vertical plane, involving a ball which is attached to a string, a roller coaster, or a Ferris wheel. So by giving you different situation, of course, the equation also different. So what is the equation? How do we get the equation? Okay, let me summarize first before we just answer some past year's question for our revision. Okay, let's start by the first case, which is a ball which is attached to a string and move in a vertical circle. Okay, so normally for any vertical plane circular motion, we are focusing on these two positions only, which is at the top, also at the bottom. Okay, so based on these two positions, we need to know what is the equation, and then how do we use the equation in calculating the values needed in that question. Okay, so let's start by the first one. Okay, so this ball just attached to a string and then it just move in vertical circle. So we are discussing about a circular motion which is in vertical plane. Alright, so at the top, what happened now? When the object just positioned at the top position to be like this, okay, the force exerted on it is 2, which is its weight, and G, which is directed downwards. Also the tension, and the tension exerted on the string now also directed downwards. Okay, because as we know, the tension must be directed out of body, isn't it? Alright, so the tension also directed downward. At the same time, the centripetal force always towards the center, isn't it? So at the same time, Fc also towards the center, which is directed downwards. Alright, so in this case, okay, as we know, everything just on y component. So we are talking about the total of Fy equal to F net. So the total of F, which is equal to F net, equals to Fc. So Fc is our centripetal force, where the centripetal force is our net force. So what force contribute Fc actually? Alright, so in this case, there are two different forces, which is W or Mg, also T. Alright, so Fc is directed downward, mg and t also directed downward. So for any forces which is in the same direction with Fc, it must be positive. So mg is positive, also t, because mg and t just directed in the same direction as Fc direction. Okay, so in this case, F net equals to MAC. So MAC is our net force, which is Fc. So F net now equals to T plus mg. Both forces now just positive. Why? Still in the same direction of Fc. Okay, so you will get T plus mg equal to mv squared over r, giving you T equals to, we just transfer mg to the other side, you will get T equals to mv squared over r minus mg. So by having minus here, giving you minimum tension, right? Because minus. Alright, this is what happened at the top position. Okay, what happened at the bottom? Alright, let's take a look for this. Okay, when the object just rotate and just reach the bottom position here, okay, so the force exerted on it still 2, which is tension, still directed outward or out of body, which is directed upward lah, through the string, isn't it? Okay, upward. At the same time, the weight or mg still directed downwards. Alright, but remember, Fc always towards the center. So where is Fc? So this is Fc. Okay, Fc just toward the center, which is directed upwards. Okay, so according to this, seems like direction of T just in the same direction of Fc, so that T is positive, while B just in opposite, mg, mg just in opposite direction of Fc, isn't it? So mg is negative, and because mg against Fc, for the direction. So again, total of Fy, okay, total of Fy equals to the net force, which is Fc. So remember again, Fc is the net force, so don't ever total up Fc with other forces. Fc should be separate because Fc is the net force. Alright, so F net equal to MAC, MAC still equal to Fc. So what force actually contribute Fc here? That one is T and B. So as we know, T is positive while B is negative, so that T minus B. It's not B, mg. T minus mg, it's not B, B just position. The force is mg or weight. Okay, so in this case, T minus mg equals to Fc. So Fc is MAC, or AC equals to V squared over R, isn't it? So the equation is T minus mg equals to mv squared over R. So by transferring mg to the other side, you will get T equals to mv squared over R plus mg. So by getting plus here, what does it mean? T is maximum. So for this case, T is maximum at the bottom and T is minimum at the top position. Okay, for the first case, this how do we get the equation? Okay, now let's turn to the before we just turn to the second case. Okay, what happened? Okay, when the rope just sagging. Alright. Okay, so now to have any circular motion, okay, the circular motion is possible as long as the cord remains taut. Thus, there is a critical minimum speed to be maintained. Okay, so V minimum needed here to ensure that the object just pass through the maximum height. Okay, so according to this, to find V minimum is quite simple. Okay, our T now equals to 0. Seems like there is no tension exerted on the string. So when T equals to 0, what happened to the equation? Mg equals to mv squared over R. M and M cancelling each other. Okay, giving you V equal to square root of Rg. So this is the minimum speed needed to maintain the motion of the object to be in circle. Okay, when the speed of the object is lesser than V min, what happen? The object just drop down there. It doesn't complete the circle. Alright, so this is the way how do you find V minimum needed, minimum speed needed to complete our circular motion. Okay, next. For the second part, we are discussing about a roller coaster. Okay, again, For a roller coaster, we still focus on these two positions, which is at the upper side or at the top and at the bottom. Okay, so at the top, the position just be like this, where the passenger just in inverted position. Okay, while at the bottom here, the position of the passenger just upright to be like this. Okay, so please refer to the first situation where we are discussing about what happened at the top here. Okay, so at the top here, as we know, the passenger just in inverted position. Okay, so as we know, W always directed downward. W is weight or mg. So mg always directed downward. At the same time, our R, okay, here R representing reaction force or normal force. So R and N still same. Okay, alright, so R just directed downward. Why? Because normal force is a force exerted by the seat to the passenger. Alright, so in this case, R is directed downward. Okay, so at the same time, we are discussing about our centripetal force, where the centripetal force always toward the center, isn't it? Center of the circle. So this is FC. Towards the center of the circle. So in this case, what happened now? Mg and R still in the same direction of FC. So both forces now should be positive lah. Alright. So again, F net equal to FC, which is MAC. So F net here involving Mg and R, they are in the same direction to FC. So that equation is R plus Mg equals to FC, where FC equals to MAC or still equals to MV squared over R. Okay, why? Because A equals to V squared over R. So by rearrange the equations, we just transfer Mg to the other side, you will get R equals to MV squared over R minus Mg. Okay, so this is the equation, okay, for this position which is at the top. Okay, what happened at the bottom now? Okay, the position of the passenger just be like this, which is upright position. Okay, so as we know, Mg is directed downward. Okay, something is wrong here actually. Mg is directed downward. I need to correct this. Sorry, this one is wrong. Mg just directed downward. This is Mg. Wait, I need to repair this. Wait for a while. Okay, so this is Mg. Okay, weight always directed downward, caused by gravity, isn't it? Okay, so Mg is directed downward, and then R just directed upward. So remember, this is the normal force. So the normal force is a force exerted by the seat to the passenger, isn't it? So the force now just directed upwards. So this is R. Again, at the same time, we are talking about the centripetal force, where Fc always toward the center of the circle. So for at this position, Fc just directed upward lah, because the center just here, isn't it? This is the center of the circle. So Fc just directed upward. So based on this, okay, what happened now? R and direction of R still same with direction of Fc, isn't it? So R is positive, while Mg just oppose Fc, isn't it, for the direction. So Mg is negative. So in this case, F net equal to Fc again. So Fc is the net force. Okay, so F here just caused by R and Mg. So in this case, R is positive and Mg is negative. So that the equation is R minus Mg. R minus Mg equals to Fc again, which is Mv squared over R. We just transfer Mg to the other side, giving you R equals to Mv squared over R plus Mg. So again, minus giving you minimum R, plus giving you maximum R. So they may ask you to calculate the maximum normal force and the minimum normal force. So based on these two equations, you will know lah. This is minimum normal force, and this is maximum normal force, which is at the bottom. Okay, all right. Again, to complete this one, to complete the circular motion, we need to ensure that the speed here should be minimum. Okay, so what is our minimum speed needed here? Alright, so again, so in this case, to ensure that the object just reach the maximum height here, so V minimum needed here. So when the speed is minimum, R equals to 0. Okay, seems like the object just reached the maximum without pressing the, what we call it, rail. Okay, so there is no R lah. So in this case, a minimum velocity when R0 is required in order to keep a roller coaster car on a circular track. Okay, so when R equal to 0, what happened? The equation just be like this. M and M cancelling each other, giving you again V min equals to square root of RG. Okay, so to calculate the minimum speed needed to complete the circular motion, okay, this is the equation where R is the radius of the circle and G is the gravitational acceleration. Okay, so in this case, this is RB lah, R at the bottom, and this is R at the top. So R at bottom is greater than R at the top position. Okay, so remember R and N still equal actually, representing the normal force. N representing normal force, R is reaction force, but they are the same actually. Okay, now let's turn to the third case, which is under Ferris wheel. Okay, before we just go through with the Ferris wheel, I want to show you what is the difference between a roller coaster and a Ferris wheel. Okay, so this is the roller coaster where the position of the passenger just be like this. At the bottom, the passenger just at in upright position, and then at the top, the position of the passenger just be inverted to be like this. Okay, but for the Ferris wheel, see what happened now? The passengers always in upright position as long it just position at the top or at the bottom position. Okay, always be upright to be like this, so that the equation for Ferris wheel and roller coaster, they are different, and because the position of the passenger also different. Okay, so what is the equation of the Ferris wheel? Okay, so let's turn to this part. Okay, all right, so what do we have now? Still the same. For the Ferris wheel, we just focus on these two positions, which is at the top, also at the bottom. Okay, so we just start by at the top position. So this is the Ferris wheel. So at the top, okay, how many forces exerted on that passenger? Still two, which is the first one is weight, which is directed downward, and the second one is normal force. So remember, R and N still the same. So the normal force. Don't forget that at this position, FC always towards the center, isn't it? Okay, so this is FC. And because FC and AC, they are directly proportional. How do we know? From the equation of F equals to MA. So FC equals to MAC. When AC directed towards the center, of course, FC also towards the center. All right, so in this case, FC is downward, which is to the center, so W also directed downwards, so that W is positive, while N is directed upward against FC, so N is negative. So again, the equation is F net on the Y component equals to F net, which is FC. So remember, FC is the net force, so we have to separate it from other forces. Okay, so total of F on Y component equals to FC. So in this case, W is positive because still in the same direction of FC, while N is negative because against FC for the direction. So Mg minus N. Mg minus N equals to FC. So FC equal to MAC or MV squared over R. So we just transfer. By rearrange the equations, you will get, and we just transfer N to the other side, and then MV squared over R to the other side, you will get N equals to Mg minus MV squared over R. So this is the equation, okay, of the normal force at the top position. Okay, while at the bottom, okay, what do we have now? All right, so still the same. weight or mg still directed downwards, and then the normal force is directed upward. Okay, why? Because the position of the passenger is still the same, isn't it? So remember, the normal force is a force exerted by the seat to the passenger. It must be directed upward lah. Alright. At the same time, AC is directed upward or towards the center. Still the same for FC. So this is FC direction lah. So FC also towards the center. Based on this, N and FC still in the same direction. So N is positive, while mg just against FC for its direction. So the mg is negative. So the equation now still the same. Okay? N minus mg equals to FC or mv squared over r. So by rearrange the equations, you will get N equals to mv squared over r plus mg. So this is N at the top and this is the N at the bottom. So again, plus giving you greater values compared to minus, isn't it? So N at the bottom, NB, greater than N at the top, which is NT. Alright, so this is the way how do we get the equation of circular motion, okay, for any case involving a Ferris wheel, a roller coaster, or a ball of stone which is attached to a string. Okay, I think you don't have to memorize all the equation. We may derive it based on the figure or simple diagram. Okay, now let's start the discussion by answering one or two past year's question from chapter 6 which is under circular motion. So remember, we are focusing on vertical circular motion. So I just select some question which is related to our vertical circular motion. Okay, let's say the question just be like this lah. Okay, this is one of the past year's question. I'm not so sure which year is that. Okay, first they ask you to define what is centripetal force, and then second, a rock of mass m is attached to a string of length L. The rock is swirled with constant speed v in a vertical circle. Given that T max is the maximum tension in the string and g is the acceleration due to gravity. Okay, sketch a diagram to show all the forces acting on the rock when it is at the top of the circle and at the bottom of the circle. See, they will ask you to calculate something which is at the top, also at the bottom. Okay, and then write an expression for T max and T min in terms of m, v, l, and g. Okay, according to the info given just now. And then when mass of rock is 250 grams, okay, in gram. So remember, we need to convert it to be in kilogram for our calculation. Length of string is 50 centimeter. Again, centimeter, convert it to be in meter. And a speed is 15 meter per second. Okay, SI unit already. So calculate the value of T max and T min with its direction. Okay, so we need to know the direction of T. Is it upward or downwards? Okay, and then for the third case, by giving you a pail of water at the end of a rope is swirled in a vertical circle, explain why the water does not spill from the pail when the pail is at the highest point. See at the top, and seems like the bucket just in inverted position, isn't it? But the water inside the bucket still doesn't spill out there. So why? Okay, so how to answer this question? Okay, let's start by the first one, which is the definition of centripetal force. Okay, centripetal force is defined as the net force required to keep an object of mass m moving at a speed v on a circular path of radius r. Okay, I think we have this already in your notes, so you may refer to your notes. Okay, I want to focus on calculation. Okay, for the second part, which is B. Okay, for question B, what do we have now? First, by giving you length equals to L, and then the speed is V, and then the other info given is T max, also T min. Okay, the mass is M. And then the gravitational acceleration is G. And then they ask you to find T max and T min equation, isn't it? T max, also T min equation. So first they ask you to sketch a diagram. According to the question, they ask you to sketch a diagram. Okay, let me change the color first. Or I want to use this better. Okay, so first they ask you to sketch a diagram. Alright, for the second part, they ask you to find the expression of T max and T min. Oh my god, yeah. Alright, and the third one, they ask you to calculate T max and T min. Okay, now let's start. First, they ask you to sketch a diagram to show all the forces acting on the rock. Okay, so how is it? And we just take out a circle first. Okay, and then there is the two different positions, which is at the top, also at the bottom. Okay, so this is the center lah. Alright. Okay, so now sketch a diagram to show all the forces acting on the rock when it is at the top of the circle and at the bottom of the circle. Okay, what force do we have now? Okay, let me use different color. Okay, first, of course, weight. And then the second one is tension, isn't it? At the top. Alright, and then at the bottom, what do we have? Still weight. Also the tension. Tension must be directed out of body lah, through the string. Okay. For me, I like to label FC also to avoid any mistake lah for my calculation later. So using different color, I want to show you the direction of FC. This is the orange one lah. So this is FC. And we know that FC is the net force. Actually, we don't have to show it, but for my safety in calculation, I like to show that. Okay, so this is the answer for question B1. Sketch the diagram to show all the forces acting on the rock when it is at the top of the circle and at the bottom of the circle. Alright, so at the top, I need to label it better. Okay, better we just label it because we can see clearly the answer for which part actually. So this is at the top. And this is at the bottom. Okay, settle B1 settled already. Okay, now B2. Write an expression for T max and T min in terms of M, V, L, and G. Okay, so we need to answer question B2. Write an expression for T max and T min in terms of M, V, L, and G. Okay, so let's start by at the top. This is B1. Okay, B1. And this is B2 lah. Wait, I need to make it clear lah better. And this is B2. Okay, at the top, what happened? What is happening at the top actually? Alright, so at the top, what do we have now? Okay, so the equation still the same. Okay, using black lah, better we can see it clearly. So sum of Fy equals to Fc lah. So in this case, okay, so W and T still directed downward, which is equal direction to Fc, isn't it? So W and T is positive lah. Okay, so the question is W plus T equals to Fc. So that T equals to Fc minus W, giving you Fc is mv squared over r and W is mg, so that we may simplify it to be m multiplied by v squared over r minus g. So this is T, and by having negative here or minus, we know that T here should be T min. Okay, the tension is minimum here. At the top, the tension is minimum. Okay, what happened at the bottom? Okay, so at the bottom, we just do the same thing lah. Okay, so at the bottom, still the same. Okay, so sum of Fy equals to Fc. Okay, what do we have now? So this is Fc. Fc just towards upward lah, directed upwards. So in this case, T is upward, so that T is positive, while W is downward, so W is negative. So the equation is T minus W. Okay, so T minus W equals to Fc, so that T equals to Fc plus W, which is m v squared over r plus mg, or we may simplify it to be m multiplied by v squared over r plus g. So this is T, and again, by having plus here, means that the T is greater, which is maximum lah. Okay, so T is maximum here. So at the bottom, T is maximum. Alright, so I think we have complete the second question, which is number B2. Where is it? Okay, complete already, B2, settle. Alright, next. When mass of rock given already now, also the length, also the speed, they ask you to calculate the value of T max and T min. Alright, so by using the equation getting before, then we just calculate the answer. See, they are related to each other. So by getting wrong for the equation, of course, the answer for B3 also wrong, because B2 and B3, they are related to each other. Okay, so let's answer question number B3. They ask you to calculate the value of T max and T min. Alright, so again, at the top, and the question is T min. T min equals to m v squared over r minus g. Okay, substitute the values given now. The mass given is 250 grams, convert it to be in kilogram. So 0.250 kilogram. Okay, mass. Multiplied by V. V given is 15. Where is V? Check it. Okay, V is 15. The length is 50 centimeter. Okay, so make sure for the substitution we have to convert everything to be in SI unit. So this one is 15 squared over R given is 0.5 lah, because 50 centimeter equal to 0.5 meters minus 9.81. Okay, so that you will get T min equals to, okay, 110.05 Newton. Settle T min. Okay, we just do the same thing to calculate T max. So at the bottom, okay, so the equation is T max. T max equals to m v squared over r plus g. Okay, substitute all the values. The mass given is 0.250 kilogram, multiplied by the speed still the same, 15, over r still the same, 0.50 plus 9.81. Okay, and then you will get the answer, which is equals to 114.95 Newton. Okay, I think something is missing here. Read the questions carefully. Okay, with its direction. See, some marks given for the direction. So without direction, you will lose some marks lah. Okay, so we need to explain the direction. So in which direction is that? Okay, so T min, okay, at the top, T is directed downwards, kan? So here we need to answer it lah, which is downward. And for T max is at the, where is it? T max at the bottom, kan? Okay, T max at the bottom, which is directed upwards. Okay, settle. Alright, so we have complete question number B3. Done. Okay, and then for C, a pail of water at the end of a rope is filled in a vertical circle. Explain why the water does not spill from the pail when the pail is at the highest point. Okay, so what is the answer? Okay, I typed already the answer because I don't want to write it using because my handwriting is quite bad. Okay, so oh my god, sorry. So what is the answer? When a pail of water is swung in a vertical circle, the water does not fall out at the top of the loop when the speed is great enough. So the keyword is the speed great enough. Alright? At every point in the circle, the water tries to fall vertically. Okay? Due to gravity, but also try to move in a straight line due to its circular motion. See? So we have two different motion actually. Seems like they just cancel each other lah. That is why the water doesn't spill out. Okay. Alright. Okay, next. Alright, next question. This is also the past year's question, which is from I think batch 2008-2009. This is past year's. Question is from 2008-2009 batch. Okay, so what is the question? Okay, it's quite interesting. Okay, so figure 6 shows a 0.3 kilogram object attached to a horizontal rod. Okay, now this is an object, okay, attached by two strings connected to a rod, and then the object just rotating to be like this. So we can see the circle not just on vertical, isn't it? So we are talking about a vertical circular motion. Okay, all right. So each length of 0.5, the length of the string is 0.5 meters. The object is wheeled with speed of 8 meters per second. The speed given already, tangential speed around the root axis. Calculate the tension in the string when the object is at the lowest point, which is here, and then at the highest point, which is here. Still the same, at the top, also at the bottom. Lowest point at the bottom, and highest point is at the top. So they ask you to find the tension. What is the tension? Okay, how is it? Okay, we need to sketch a diagram to answer this question. Okay, let's start by the lowest point. Okay, so what happened now? At the lowest point, okay, the situation just be like this. Okay, the first one. Okay, this is the road, and then this is the object connected, okay, by to a string, okay, and then rotating to be like this. This is the circle made by the object. Okay, so now how many forces do we have? Okay, how many forces exerted on that body actually? Okay, so what do we have? First, W, and then tension, also tension. Alright, so seems like W is really on the Y component, but T is not really on Y, it's not really on X, isn't it? So T is in combination of X and Y, so that we need to resolve T to be on Y. Okay, why? Because seems like this is the center of the circle. Alright, so our FC just towards the center. This is FC. Okay, so that we need to resolve T to be TY lah. Okay, so the length here is given, and length here given as 0.5, isn't it? Also 0.5, and the length here given is 0.6, 0.6. So half of that, this length is equal to 0.3. So first we need to find the angle here, theta. Using this triangle, find theta. Okay, so take out the triangle first. Okay, so this is theta. The length here is 0.5, and the length here is 0.3. Okay, how do you calculate theta? Okay, so this is opposite and this is hypotenuse. So using sine, isn't it? Sine theta equals to 0.3 over 0.5, giving you theta. Theta equal to arc sine 0.3 over 0.5. So that you will get theta. Theta equals to 36.87 degrees. Okay, that one is theta. Okay, and then remember, according to the circle, this is the radius of the circle, isn't it? So this is the radius of the circle lah. Okay, because this is the circle, so the radius should start from the object to the center. So this is radius. So we need to find R. How do you calculate R? Okay, using theorem Pythagoras kan. Okay, so R equals to 0.5 squared minus 0.3 squared and then square root. Okay, you will get R. So R getting here equals to 0.4 meter. Using the triangle. So remember, R squared plus 0.3 squared equals to 0.5 squared. So 0.5 squared minus 0.3 squared equals to r squared. Transfer square to the other side, you will get square root. So this is the way how to calculate r. Okay, so now seems like we need to resolve t, isn't it? Okay, so what do we have? By resolving t, you will get tx also ty. Okay, again tx also ty. Okay, how many ty do we have? 1 ty, another 1 ty, so 2 ty, isn't it? Okay, so this is fc. fc is directed upwards. ty and ty still directed upwards, so positive. w against fc, isn't it? So w is negative. So what is the equation now? Okay, so sum of fy equals to fc. So how many forces do we have on y? ty, and w. So ty plus ty minus w equals to fc. Alright, so this is the equation at the lowest point or at the bottom. Alright, so let's arrange the equations. So ty equals to ty here touched by the angle, isn't it? So should be t sine or t cos, because the angle is here. This is the angle theta. Touching by the angle should be cos, isn't it? Alright, so the question is t cos theta plus t cos theta minus w equals to fc, which is 2t cos theta minus w equals to fc. fc equals to mv squared over r. Okay, substitute all the values and then you will get t. Okay, so 2t cos 36.87 minus w equals to mg. Okay, I need to change this one better. W equals to mg. Okay, so the mass given here equals to 0.3, isn't it? Okay, g is 9.81 equals to mass 0.3 again. The speed given now is 8 meter per second. Don't forget squared over r. Okay, r is the radius of the circle calculated before. So r is 0.4. Okay, so giving you the tension equals to what is the answer? Okay, 31.84 Newton. So this is the tension at the lowest point. So remember, at the lowest point, T, is it maximum or minimum? Try to recall back. We have learned before. Where is it? Okay. The tension. Where is the tension? Okay, here. So T is maximum at the bottom, isn't it? So at the bottom, T should be greater than T at the top. Okay, alright. So we have complete C1. See, the mark given is 10 marks. So it's not, it's quite high for the marks given now. Okay, so let's continue by the second part at the highest point. Okay, so highest point should be smaller than lowest point. See, the lowest point is 31.84 Newton. Okay, now for the second part B. Okay, I think we need to sketch the diagram again now. Okay, for the second part. Okay, this is the sorry, wrong position. Okay, this is the road. Alright, and then this is the object. So this is the string. Okay, alright, then this is the circle. The circle, okay. Alright, so okay, first we need to identify all the forces exerted on the body. So what do we have? W, tension, also tension. And so remember, tension should be out of body. See, this is tension actually, out of body. Tension. Okay, still the same. We need to resolve T to be Tx and Ty, isn't it? Okay, so this is Tx, this one also Tx. So Tx and Tx cancelling each other, they are equal in magnitude. Okay, so this Ty and the other Ty. Okay, at the same time, where is Fc? Fc still towards the center, then so this is Fc towards the center. Alright, so in this case, okay, listen carefully. What do we have now? On the y component, wait, okay, on the y component, what do we have now? Okay, there are three forces, which is Ty, Ty and W. At the same time, this is Fc. So Fc is directed downward, which is towards the center of the circle. This is the circle. So this is the center of the circle. So Fc is towards the center. So Fc is downward. At the same time, Ty and W also directed downward. So Ty is positive, same direction with Fc. Also the second Ty, also W. Alright, so what is the equation now? So the equation is, again, sum of Fy equals to Fc. On the y component, what do we have now is Ty plus W equals to Fc. So everything just plus, because all the forces now just directed downward, same direction with Fc. Alright, so what do we have now? Ty is still the same as before, according to the triangle, and touched by the angle should be cos, isn't it? Okay, so should be T cos theta plus T cos theta plus mg equals to Fc, which is mv squared over r. Okay, I think I need to show you the triangle so that you can see it clearly. Okay, so the triangle just be like this. It's quite difficult using this one. Okay. All right, so where is theta? This is theta. Okay, and then so this is W, also Ty. Ty and Ty. Okay, so Ty touched by the angle should be cos lah, because this is T. So Ty should be in cos because Ty touched by the angle here, so it must be in cos. Okay, so by doing the same thing, okay, t cos theta plus t cos theta plus mg equals to mv squared over r, so that you will get 2t cos theta plus mg equals to mv squared over r. Okay, substitute all the values again. So 2t cos, the angle still the same as before, which is 36.87. Okay, plus mass is 0.3, g is 9.81 equals to, again mass is 0.3, the speed is 8 meter per second, don't forget square there, and then over r. So what is r before? R before is 0.4. Okay, so that you will get t getting here now equals to 28.16 Newton, which is smaller than before, isn't it? That one is t mean. Okay, settle. Alright, so this is the example. How do we answer the question? Okay, so we need to know what is the question at each position. Okay, that's why I'm telling you before, we don't have to memorize the equation, but we need to understand, okay, how to sketch the diagram, how to take out all the forces exerted on the object, and then how do we use the equation in calculating the values needed in that question. Okay, so later, please check this. Okay, we need to know what is the equation at each position for each cases discussed just now. Okay, alright, I think that's all for today. Okay, I think you need to answer more questions later to understand the concept. Okay, I think that's all from me. Thank you. Assalamualaikum.
Okey, terima kasih saya ucapkan kepada kedua-dua pensyarah pembimbing kita pada hari ini. Semoga ilmu yang para pelajar perolehi pada hari ini dapat dimanfaatkan dan dapat meningkatkan kefahaman pelajar-pelajar STS dalam chapter 6. Okey, link kehadiran bagi program pada hari ini akan diberikan selepas ini dan saya minta kepada semua pelajar yang menonton dapat mengisi borang kehadiran berkenaan untuk memudahkan proses kami merekod kehadiran para pelajar. Okey, kita bertemu lagi dalam siri 6 yang akan datang dan saya ucapkan jutaan terima kasih kerana sudi bersama-sama kami untuk menimba ilmu. Ingat, jaga SOP, #kita jaga kita, stay safe. Dengan itu, saya tutup majlis kita pada hari ini dengan lafaz wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.